Hello. In the previous lesson, we have learned how to calculate the equivalent weight of the substances involved in disproportionation reaction. Today, we just consider some examples of disproportionation reaction, and we will learn how to calculate the equivalent weight of the substances. Our first example is phosphorus molecule reacts with sodium hydroxide solution, aqueous sodium hydroxide solution, to produce sodium hypophosphite NaH2PO2 plus phosphine PH3. Okay, the oxidation number of phosphorus is changed from 0 to plus 1 here and 0 to minus 3 here. So in this reaction, phosphorus acts both as oxidizing agent as well as reducing agent. So this is a disproportionation reaction. We can think this reaction in this way, or we can write the ionic equation of this reaction in this way, that P4 to H2PO2 minus 4 atoms of phosphorus here, so it is 4, and the oxidation number of phosphorus is changed from 0 to plus 1, that is 1 phosphorus atom releases 1 electron, so 4 phosphorus atom releases 4 electrons. This is our equation number 1. This is our oxidation reaction. This is our oxidation reaction, and P4 is reduced to phosphine after accepting 12 electrons, because the oxidation number of phosphorus is minus 3 here, here is 0. So after accepting 12 electrons, it will be transformed to 4 molecules of phosphine. So this is our reduction reaction, this is our reaction number 2. So if we balance this reaction, we have to balance the electrons. 4 electrons are involved here and 12 electrons are involved here. So we have to multiply this equation by 3, and adding equation number 2, we have P4 plus 3P4 plus P4. That we can write in this way. This phosphorus, this is 3 into P4, and for this phosphorus, this is P4. Is H2PO2, 4 H2PO2 minus, and 4 PH3. Sorry, it is 12 H2PO2 minus plus 4 PH3. So we can think this reaction in this way, that P4, there are 2 types of P4. Here is a P4 molecule, here is another P4 molecule. So 3 P4 molecules is required for the oxidation process, and 1 P4 molecule is required for the reduction process. So this P4 molecule is oxidized to 4 H2PO2 minus, and this P4 molecule is reduced to PH3, 4 PH3. Here it is 12 H2PO2 minus. So we can think this reaction in this way, that phosphorus oxidation number 0, here it is plus 1, here it is minus 3, and here it is 0. So this 3 phosphorus molecule actually releases 12 electrons. 12 electrons here, and 4 into 3, 12 electrons here, and these 12 electrons are accepted by this P4 molecule to produce the phosphine. So we can think 12 electrons actually transferred between these 4 from this 3 P4 molecule to this P4 molecule, so that this one is oxidized and this one is reduced. So the N factor of this reaction, so the N factor of phosphorus here equal to total number of electrons transferred, this is 12, and these 12 electrons are transferred between these 4 phosphorus molecules. So this is 4 is the total number of molecules, 3 plus 1. So the N factor is 3 here. So the equivalent weight the equivalent weight of phosphorus, equivalent weight of phosphorus equal to molecular mass of phosphorus divided by the n factor is 3. The molecular mass of phosphorus is 31 into 4 divided by 3. So this is 4 by 3. This is 10.33 into 4. This is 41.33. This is the equivalent weight of phosphorus in this reaction. Okay. Let us take the second example, or example 2. Let us take the second example. Example 2, we know when potassium chlorate KClO3 is heated, it produces KClO4, potassium perchlorate, plus potassium chloride. This is again a disproportionation reaction. The oxidation number of chlorine is plus 5 here, oxidation number of chlorine is plus 7 here, and it is minus 1. So we have to write the ionic equations. ClO3 minus, after releasing 2 electrons, it will produce ClO4 minus. So we can write the oxidation number of chlorine is plus 5, here is plus 7, 2 electrons are released from this chlorate ion, and again ClO3 minus, the oxidation number of chlorine is plus 5 here, it is reduced to Cl minus after accepting 6 electrons to Cl minus. So if we want to balance these two equations ionically, we have to balance the number of electrons, that is 2 electrons involved here and 6 electrons involved in the reduction process. So multiplying equation 1 by 3 and multiplying equation 2 by 1 and adding these two equations, we have 3 ClO3 minus, that is this 3 ClO3 minus is required for the oxidation process, and again ClO3 minus, this ClO3 minus is required for the reduction process. So actually 4 ions of ClO3 minus is required for the overall disproportionation reaction. It's 3 ClO4 minus plus Cl minus. So actually the balanced equation is 4 KClO3 on heating produces 3 KClO4 plus 1 KCl molecule. This is our balanced equation. Now we have to calculate the equivalent weight of KClO3. We can write ClO3 minus, two types of ClO3 minus are involved here. ClO3 minus here and ClO3 minus here. Now 3 ions of ClO3 minus is required for this oxidation process, and 1 ClO3 minus is required for the reduction process to produce Cl minus. So actually the oxidation number is changed from plus 5 to plus 7, and here plus 5 to minus 1. So we can write in this way that 2 into 3, that is 6 electrons. 6 electrons is transferred between these 6 electrons is exchanged between these 4 chlorate ions. So the N factor of this reaction, N factor of chlorate in this reaction equal to total number of electrons transferred. This is 6 divided by 4. Why it is 4? Because 4 chlorate ions are involved here. So this is nothing but 3 by 2. So the equivalent weight of KClO3 in this disproportionation reaction equal to molecular mass of KClO3 divided by 3/2. This is the N factor. And by putting the atomic mass and atomic masses of the atoms, we can calculate the equivalent weight of KClO3. Okay, this is our second example. Our third example is this. We know our third example, we know HNO2, this is nitrous acid. On heating, it produces nitric acid plus nitric oxide plus water. This is again a disproportionation reaction because the oxidation number of nitrogen is +3 here, is +3 here, here it is +5, here it is +2. So we can think this reaction in this way, that NO2 minus actually releases 2 electrons to form NO3 minus plus 2 electrons. Here it is +5, here it is +7, here it is +3 and here it is +5. This is your equation number 1. And again NO2 minus is reduced to NO by accepting 1 electron to produce NO, because the oxidation number of nitrogen is +2 here and the oxidation number of nitrogen is +3 here. So if we want to balance this reaction, we have to multiply this equation by 1 by 1 and this equation 2 by 2. Then we have NO2 minus, this NO2 minus is oxidized and this 2 NO2 minus is reduced to form NO3 minus plus 2 NO. Okay, so the balanced ionic equation is 3 NO2 minus is disproportionates to form NO3 minus plus 2 NO. Okay. Now we have to calculate the equivalent weight of NO2 minus in this reaction. NO2 minus, again we can consider in this way that NO2 minus, there are 2 types of NO2 minus. NO2 minus here and NO2 minus here. Oxidation number is +3 here, oxidation number is +3 here. This NO2 minus is oxidized to NO3 minus, the oxidation number is +5 here. And this NO2 minus is reduced to NO, oxidation number of nitrogen is +2 here. So there are 2 NO2 minus are involved in the reduction process to produce 2 NO. Now we can think this reaction again in this way, that 2 electrons is transferred from this nitrite to this nitrite, so that these 2 nitrates are reduced to NO and this 2 nitrite, this nitrite ion is oxidized to NO2 minus, NO3 minus nitrate. So the N factor of this reaction, N factor of NO2 minus in this reaction is total number of electrons transferred, this is 2, and total number of ions involved, this is 3. The N factor is 2 by 3. Then definitely equivalent weight of HNO2 equal to molecular mass of HNO2 divided by 2 by 3. This is N factor. Okay, this is our example number 3, and let us take another example. Equation number, or example number 4. This is also an important reaction. We know H2O2 decomposes to produce H2O plus oxygen. This is a well-known disproportionation reaction. We have to calculate the equivalent weight of H2O2 in this reaction. and of course by calculating the N factor. Here the oxidation number of oxygen is -1 here, here it is -2 and here it is 0. So the oxidation reaction, we can write the oxidation reaction in this way, that the O2 minus, the O2 minus, the peroxide ion is oxidized to oxygen. Oxidized to oxygen. The oxidation number of oxygen is -1 here and it is 0 here. So there are 2 electrons are released. In the reduction reaction, we can write again O2 minus, this is our peroxide ion, accept 2 electrons to produce 2O2 minus. This is our oxide ion which is present in water molecule. So the oxidation number of peroxide is -1 here and the oxidation number of oxygen is -2 here. So 2 oxygen atoms accept 2 electrons to form oxide ion. So the N factor of this reaction can be calculated in this way. We can write the H2O2 in this reaction. So there are 2 types of H2O2. One H2O2 is oxidized to oxygen and one H2O2 is reduced to H2O. This is -1, -1, 0, -2. So actually 2 electrons, 2H2 here, actually 2 electrons is released from here to here to produce water. H2O2 is oxidized to oxygen and H2O2 is reduced to water. So we can calculate the N factor of this reaction in this way. The N factor equal to total number of electrons transferred, this is 2, divided by total number of molecules involved, this is 2. So the N factor is 1 here. This is a very important reaction. Look at here again. When H2O2 is oxidized, there are 2 electrons are involved, and when H2O2 is reduced, there are 2 electrons involved. That is, when H2O2 acts as a reducing agent, its N factor is 2. When H2O2 acts as oxidizing agents, its N factor is 2. But in the disproportionation reaction, the N factor of H2O2 is 1. This is very important. So the equivalent weight of H2O2, in this disproportionation reaction equal to molecular mass of H2O2 divided by its N factor, this is 1. Molecular mass of H2O2 is 34 divided by 1, this is 34. This is the equivalent weight of H2O2 in this reaction. Okay, this is all about disproportionation reaction and calculation of equivalent weight. Thanks for watching the video.